Hello and welcome back to Friday Minis. Now, if you've written any amount of code, you've probably come across the problem of trying to represent multiple states. Here's the deal. Let's say you're writing a function, right, and it will return, one of 5 error codes, let's say. And assuming you're using a slightly more restrictive programming language like, say, C or Java, well, you're not going to be able to, just return a string and have that string describe what the state is, right? You're probably going to have to return an integer. That poses an additional problem because then you're going to have to know what that number actually means. If I give you error 5, you're going to have to look it up to see what error 5 is, and that's not great. This is particularly bad because these are essentially magic numbers, right? One big thing in software engineering is you shouldn't have numbers that are just there because their meaning is notoriously unclear. So, we can fix this by creating constants. Instead of giving, 1, 2, 3, 4, 5, we'll have a set of constants at the top of our code, and later on, we'll refer to things by the constants. So yeah, that's cleaner because your function returns based on a constant. Your error checking code later on can also refer to the constants, so that's very nice. This is essentially the start of what we'll call enumerations, where we have to use numbers to represent a set of things, but instead of doing that, right, we alias it with something, usually a constant name, and yeah, based on that, our code becomes more readable. One interesting side effect of this is that, the actual number no longer matters. I don't have to say 1, 2, 3, 4, 5. I can say 100, 200, 300. It doesn't matter. At the end of the day, if you change the constant, with the same code, everything is still going to work the same. Of course, that's assuming that you've used the constant everywhere, and at no point of time have you actually hard-coded the number itself. What this gives us is an additional level of abstraction. Even though it's numbers moving around under the hood, we don't care. We only care about its semantics, right? Its actual meaning. Some programming languages like Java actually take this one step further, where they allow you to create enumerations. This is an example of an enumeration in Java. Essentially, the values inside still work the same as the constants we've seen just now, but the difference is, you don't even bother specifying the actual number it represents. In fact, what Java does is it translates this to some kind of class under the hood. It actually even implements a set of class features. But the key point is, from our point of view, we don't care. We just use the enumeration, right, in the same way as, we've discussed earlier, and the right thing happens. Abstraction. We don't care about the implementation details, and this is a great example of that in action. So yeah, that's enumerations in a nutshell. When you want to push numbers around, but you don't care about the numbers themselves. You have a special meaning attached to each number. You can do this as constants, or you can do this as enumerations if your language actually supports it. So yeah, there you have it. That's all there is for this episode of Friday Minis. I hope you've gained some insight today. But until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.